Hey there, welcome back to Water Finance and Management Conversations. I'm your host, Andrew Farr, Managing Editor of Water Finance and Management, and I'd like to welcome my guest today, Paul Acosta, Senior Condition Assessment Specialist with Xylem. And today, Paul and I are going to have a quick conversation about large diameter condition assessment, and we're going to focus on transmission mains. And Paul, for this discussion, we're going to, I think, rely a little bit on your in the field experience. We're very curious to hear about some things that you're seeing across the industry as it relates to condition assessment for large diameter transmission lines, some things that you might be seeing, some common recurring challenges or misconceptions, and any other best practices you can share with us as utilities look to manage their large diameter lines. Of course, there's a huge cost component associated with transmission lines, so prioritization is of the utmost importance. So, Paul, I'd love to start you off with this question right here. What would you really say are some of the essential elements of a pipeline condition assessment program for a utility?
In my professional opinion, a successful condition assessment program starts with the plan and is well supported by the director's office, finance, engineering, maintenance, operations, and the procurement department, and possibly utilizing external consultants to assist you. And then one of the other key elements is making sure that you either have an internal subject matter expert. If not, create a subject matter expert internally with the program. And what is most important is that you also create a succession plan for those that are there when they leave, retire, or what have you. Somebody else is able to pick up the duties from the original program manager. So the succession plan is very, very important. Once you've achieved that, now you could start creating a pipeline criticality list. The pipeline criticality list can be of transmission mains or distribution system. It is dependent on which route that you're going to select, and then determining what your next steps forward are. And what is key in that is pipelines. You're going to be utilizing technology as a tool and trying to determine if you're going to utilize direct or indirect testing methods for your pipelines. And the costs are associated, lower cost for indirect testing methods versus direct testing methods. Moving forward, you need to know, are the inline valves working properly? Can you operate them? Do they isolate? And also, if we're talking specifically transmission mains, is there vaults installed to where you could actually get inside the pipe in order to do some inspections or perform man entries? Those are all important in this condition assessment program.
And that really leads into my next question, because all those things that you're talking about there, I think, are geared towards utilities being a bit more proactive about their pipeline management, whereas in the past they were a bit more build it and forget it. We know that utilities are much more proactive about their infrastructure management these days. What else should they really be thinking about to stay proactive when managing their large diameter transmission mains?
That's a great question. To be more proactive on specific pipelines is essentially knowing the utilities asset management and like their work order flow. So specifically, let's talk about the distribution system. In a distribution system, you have work orders for where pipelines continue to break, to leak, and the maintenance crews have to go out and take care of these. If you utilize all the work orders and the call logs that come in for all these small pipeline failures, you're able to produce kind of a heat map of where all these assets are located, so you could focus your CIP funding on where to replace and remove and replace for new pipelines. This will help you in the distribution system. In the transmission mains, of course, age is always something that everybody looks at, but it's not necessarily the driving force. So we need to look at the criticality list and say, for instance, if there's some hospitals, dialysis centers, or any critical infrastructure that are in that location of the transmission mains, of course, you're going to want to focus your efforts in those areas because the consequence of failure is a lot higher. I mean, also, if there's schools located in this area, so that it's important to fully utilize that criticality list and a matrix that has all of your assets weighted properly.
And on the other side of that, Paul, what might be some elements of a condition assessment program that get overlooked? And I'm thinking of things like corrosion protection. Not that corrosion gets overlooked, but perhaps approaches in keeping tabs on corrosion may differ. What can you tell us about that?
As I mentioned before, some things that get overlooked is having the internal employees to perform all this work that's needed in a condition assessment program. Sometimes a utility doesn't have it. So it's important to have a contract vehicle that you could utilize as an extension of your workforce. So for number one, you're able to use them as your subject matter experts and being able to plan and develop these projects for your pipelines, whether it's distribution or transmission mains. But you're also developing your internal employees through that extension of a contract with a consultant. So you're training your people internally. And again, it comes back to the succession planning. It's important that way when somebody does leave, another person can step up and carry on the program. I know that I mentioned it earlier, but it's very, very important for a utility to continue this process.
What could you tell us about utilities that perform condition assessment? Now they have this data. What's next with the data? We talk so much about data analytics, data management. What's the next step for that data to really make sure that they are prioritizing rehabilitation, replacement projects properly?
During your process of performing condition assessment, you will be collecting a lot of data, whether it's leak detection, whether it's electromagnetic testing, and these ones are kind of like your direct testing methods with say pipe diver or smart ball, and indirect could be very easily your over the line close interval potential surveys as well as straight current interference testing. All of this data needs to go into one location. So that way you could layer all of the data, whether it's with charts and graphics, and that way you'll be able to perform a very good analysis. So it's key to know where these corrosion hotspots are so you could evaluate them. Because the first line of defense against corrosion is a very good coating. From there, you're able to apply cathodic protection to a pipeline. And cathodic protection is the reduction of the corrosion. Corrosion will always happen. We're just now moving it from one place to the other. And utilizing testing, you're able to determine where these hot spots are that you're able to prevent corrosion on. And so you're basically looking for these anodic areas. There's impressed cathodic protection systems. There's also sacrificial cathodic protection systems. And in my old company at Tucson Water, I was able to document where corrosion that existed on a pipeline, it actually aligned properly with some electromagnetic testing that we performed. And so it's good to have these direct and indirect testing methods. And so you could fine tune your matrix or your pipeline criticality list with this type of analysis. When we start touching more on pre-stressed concrete cylinder pipe, now that pipe material is very, very important because the pre-stressing wires are stressed to 75% of its ultimate tensile strength, which leaves absolutely no tolerance for corrosion whatsoever. So applying cathodic protection is a good thing, but it is very, very important to have a subject matter expert who will design and monitor the cathodic protection on a pre-stressed line, because it could also create problems for you, and problems that I'm referring to is like hydrogen embrittlement on a wire. So it's always very, very important to know your pipe material, what you want to do, how you're going to do it, because sometimes applying these new technologies to your pipeline at some time can create harm for you.
Paul, it's been a pleasure talking to you for a couple minutes today. I really wanted to get, as I mentioned, some of your firsthand perspective on some of these points, and I think we accomplished that. So thanks very much for taking a few minutes to chat with us today.
Thank you.
And that'll do it for another edition of Water Finance Management Conversations. For Paul Acosta with Xylem, I'm Andrew Farr. We'll see you next time.
Subscribe to Water Finance and Management's YouTube page and visit waterfm.com for the latest water industry news and insight.